Hello, I'm Jack Koenig with Graco Industrial Lubrication Equipment, and I'm back with another video in the series on wiring the GLC X controller. This video will be covering the G3 standard pumps, especially the ones with the 5-wire cable. These are kind of the special pumps that we use in our yellow iron kits, and so far this is the one I've been getting the most requests on how to wire. What makes those CPC5 cables special is that the low level signal is actually carried on 2 of the wires in that cable so that you only have to route 1 cable, which is why it's a favorite for the yellow iron kits. But in case you have the traditional CPC cable with the separate M12 cable for the low level output, I will be showing you along the way how to incorporate these cables into the same harnesses. So let's take a look at how all that's done. Most of the requests that I've received so far have been for how to just directly wire the 5-wire cable onto the 20-foot harness with the amp seal connector on it already. The 5-wire cable in this case doesn't need the green, so I have just snipped the green off from the 5-wire, and we're going to use these other 4 that are left. And then on the 20-footer, blue is actually the pressure input. I'm setting this up for series progressive, so this will get cut off. But if you did want to do a pressure system with injectors and then a vent valve on your G3, this white wire can either be an alarm output or power a vent valve. So just keep in mind that if you want to have a separate vent valve power line for a G3 that's pumping to injectors, you can do that with the white wire. Since I'm not using it, I actually disabled it in the controller, but I'm also going to tape it off instead of just cutting it to keep those conductors away from causing any trouble. And then this little black wire, there are 2 blacks, a thicker one and a thinner one. The thin black is the ground for the white, so whether you're using it with a vent valve or with an alarm output, this is your ground to complete this circuit. Speaking of the vent valve, you would put blue from the vent valve on black and brown from the vent valve on white. So enough about those systems, because that's not what we're doing today. Remember, before we proceed, if you want to use a piece of heat shrink, now is the time to slide it onto the cable, because once the connections are on, you're not going to be able to get it over this guy. So if you're going to use a piece of heat shrink, slide it onto your cable now. Before we get into our actual connections, if you've watched my other videos in this series, you've already heard me say this a couple of times, but we don't want to use solderless butt connectors for anything involving mobile equipment because they're not as trustworthy as soldering. But instead of getting out your soldering iron, you can also use a soldered butt connector, and that involves using a heat gun. So maybe you already knew where I was going because you saw the heat gun. And when you're using these connectors, you want to be able to twist the wires together a little bit. So let's start with our ground for our pump power. And I was already working with these a little bit off camera, so I've got somewhat of a twist. But we're going to twist these. Oops, that fell right off. And that's actually why we want to do this twist, is we want to twist these together to provide a little bit of structure here. So now the 12-wire loom on that 20-foot harness actually has a stiffer metal for its conductor, so it's a little bit hard to twist them evenly, but you want to do that as best as you can. So now black goes to black. That's pretty straightforward. And now we can carefully turn on the heat gun and try not to move this. And now we just use the heat gun to melt these together. And it's kind of a 3-handed job, which is why I put that twist on there, because it will help me hold that in place so it doesn't pull apart while both my hands are busy holding each end of the cable. All right, I can see the solder getting nice and melted in there. The one thing about this though is I like this particular heat gun because it has a base that allows me to sit it upright like this. But I'm only getting that one side, and I still want to melt the side that's on top now. So I'm going to pull this away a little bit and set this down carefully. And now I'm just going to hit this from the top here. just enough to see everything melt and make sure that the ends of the connectors have kind of come down around the wire itself. So I'm going to give this a little time off camera and I'll be right back. Now that's a nice strong connection. You have to pull pretty hard to pull that apart. So solder is strong, and that's why we prefer it to those solderless butt connectors. Now the remaining wires on the 5-wire harness are white, orange, and red. On the 5-wire, red is your positive for the pump power, and that's just going to go to red over here on the 20-foot harness as well. But then white and orange are the low level switch, and they don't actually have a polarity, but to make it easier to remember, I suggest that you connect orange to orange. So that way you have color coding on 3 of the 4 wires, where you have, again, black to black, red to red, orange to orange, and then white is going to connect to violet, because this violet is typically the machine count input, but when you're connecting to a G3 or a G1 pump, they actually have a paddle, which is a different kind of low level switch, and the paddle signal does not play nice with the analog input on the GLC-X, so we use the machine count input instead. So that's why white is going to go to purple. But again, if you switch white and orange around and get them backwards, it's not a big deal. And also I want to point out, while we're talking about these connections, on the 3-wire harness for the G3 and G1, again, you don't use the green, and then black is still ground, so the one we did would still be black. But now the white wire here, the low level isn't on here, so obviously this isn't the low level signal. This is your positive pump power on your 3-wire cable. So you're really just using 2 of the 3 wires, the black and the white, where black is still negative and white is positive. On the M12 cable, you only need black and blue as your low level signal. And again, there's no polarity here, so you can just use whichever one. And we're still going to be going into the GLC-X on the violet and the orange. So make sure that you're matching these up. And again, it doesn't matter polarity wise, but blue and black go to orange and violet. So now let's proceed with the rest of these connections, which I'm actually going to do off screen, and I'll come back when I'm done to show you how to do the proc switch. And here we are. These 3 colors are matched up, and we got white going to violet. Now the next 3 colors that we need are yellow and gray, and then one of the greens. The other green is normally for the low level, which that's number 8, so I typically use number 13 for something else. But in this case, it really doesn't matter what color you use. These are even common to each other, but I'm using green 13 just to be consistent in case I ever have to troubleshoot this thing. So the mating colors now are kind of funny because each of them are almost a different shade of these 3, where blue goes to green, black goes to gray, or it's really called slate, but it's gray, and then brown goes to yellow, and I always think of brown and yellow as kind of similar tints. So it's easy for me to remember when I remember that they're tinted similar. So brown and green aren't even close. Blue and yellow, you could get confused, but it's blue to green, black to gray, brown to yellow. And then I need some smaller connectors now. The ones that I buy tend to be a little bit tapered, and the one end just barely fits over the thicker wire on the long harness here. So I will put it on both ways and figure out which the thicker end is, and then I actually want to then slide it onto my small wire here before I make my twist together. So now we can get our conductors here lined up again and then do our twist. All right, now I've got these twisted together well. We're gonna slide our connector up, turn the heat gun on again, and get this one melted too. That one looks good, so now I'm just gonna do the other 2 and I'll be right back. Now we're all done with our soldered connectors. We've got the colors matched up the way I described. It's kind of pretty, isn't it? I always think wiring looks beautiful and it's a shame to cover it up. And speaking of covering it up, before we slide our heat shrink down and heat that on there too, we actually want to test this harness and make sure everything works, because once the heat shrinks on, then it's a waste to cut it off and fix a mistake, and now you won't have a piece of heat shrink to slide down. So before we get too eager, let's hook up a proximity switch to the proximity switch cable, and let's hook up the CPC connector to our G3 pump and get a controller and test this out. Now I have my pump, I have my controller, and I have my proc switch. There isn't any grease in this, so we should see a low level pretty easily. Let's hit manual run. And I did program this for the paddle low level. I'm gonna hit a couple of times on my proc switch. I see that my counts are coming in, so I know my proc switch works. And there's my amber light for the alert on the low level. We know that the low level wiring is good, and we see the pump running, so we know that that wiring is good. So our harness is good, and we are done with this one. I'm gonna hit stop and disconnect all this, and we'll move on to the next section. For the sake of time, I'm going to move through this next section pretty quickly, but first I want to review the process of attaching the Deutsch pins to the M12 cables because they need a little bit of special attention. So let's revisit that real quickly right now. We're going to be building on that previous video where we already added the female Deutsch DT12 connector to our 20-foot cable. This video could also apply to working with that 3-foot cable that we sell with the connector on it already. But now we're going to use our kit that comes with the mating male connector. It's the black one with the keyways that made up to this guy. And when we're revisiting the subject of crimping these DT terminals, the pins that we sell are designed to receive anywhere from a 16 to a 20 gauge wire. In my experience, most M12 cables are actually a 22 gauge wire. So what we need to do now is strip about twice as much. So you're looking at doing about 1/2 inch or about a centimeter, and you need to fold it over. So once we have this fold, now there's enough material that when we slide our pin on and crimp it, it's going to stay put. So it's really just to make sure there's enough material there that the crimper can give the terminal a good grip on the wire. So there, it took a little bit of playing around to get that fold to go in right, but now I'm ready to crimp. And now that's not going to pull out. That's on there really firmly. You can see I already clipped the white wire off because we won't be using that, and I'm going to go ahead and crimp the other ones. Now that we've got our pins all crimped on, we're ready to put the wires into the connector. One of the easiest ways to do this, instead of even looking at a wiring diagram, is to just mate up the connector with the extension cable that was made in that previous video, because then we can see our wire colors. And right here's our orange wire, so we know we're going to be putting orange in there. And I'm actually going to pull this out so I can work with a little bit more here. Looks like that one's seated, so now we know white goes with the violet here. So we're going to put violet in, or excuse me, white in to mate with the violet. And these guys are kind of like pushing a rope, so I may have to get out my needle nose pliers, but so far so good. And then we have our red and black over here. So I'm going to tuck this through instead of twisting it around. I'm just going to put that there for the moment and get my black in there. Almost there. All right, that one's pushed in, and then red will go right next to it because that's what we saw here. We're all set with that. So now we just need to add our proc switch, and the proc switch, 2 of them go on the other end, and then 1 of them goes next to the white. So blue goes right next to the black. And this is where, if you remember from the previous video, these wires are so thin that they don't really let you push them. If you carefully press the butt end of the connector without pinching the wire, that's a good way to push it in. So then brown goes next to that, and then black goes in number 11, which is right next to the white. All of our wires are in. So all we need to do now is put in our white plugs for the unused sockets. And then lastly, I just need to find my green locking wedge to stick in here. So I'm going to go grab that right now. And there's enough space here. I might be able to just do this by hand without needing a pliers or a tool, but just make sure it's in there straight without getting hung up on any of the locking fingers. And now lock it in with my thumb. Now this is done, and we can hook it up to our other cable here. Oops, that's backwards. Hook it up the right way, and then connect to our pump and a proc switch and the controller and test it just like we did in the previous segment. And again, for the sake of time, I'm just going to tell you, go back and look at that previous segment to see how to test it, because it's the same process. So let's move on to connecting directly to the amp seal without using the Deutsch harness at all. Again, in this section, I'm going to skip right to the meat, because I've already covered in a previous video how to connect the terminals onto the end of each wire, including how to do it on the M12s. A tool you're going to want is a needle nose pliers, just because these wires are so soft. It's that comparison I keep using is pushing a rope. And this manual for the harness 26A882, it's manual number 3A7046. This is that 20-foot harness, but because it uses the amp seal connector, it has the layout and the pinouts for the amp seal. And it shows we have a 1 here and a 14 here. And when we look at the back of a connector, we can see there's a 1, a 5, a 10, and a 14. So we know it's 1 through 5 on top, 6 through 9 in the middle, and 10 through 14 on the bottom. And just with those numbers now, we can use this manual and make our harness. So the thing that everybody really wants to know at this point is what goes where, right? So we've already done the process of putting our terminals on, and I even have some of the wires in this one already. So let's just start with our incoming power. This is from our fused 24-volt power source. The white is my positive on this cable, and that goes into number 6, where you can see even on the chart here, it says power 6 white. And that's because I happen to use the same kind of cable that we use on the 20-foot harness that we make. Black goes down in the corner next to it on number 10. So here we got power 10, black, voltage source, ground. So that's pretty straightforward. And then now for the proc switch, I've done enough of these now to know that brown mates to yellow, blue mates to green, and black mates to slate. So I can go down my list here now and find yellow is number 4. So that's why I put brown in number 4, because brown goes to yellow on those other harnesses that we made. Blue goes to green, and black goes to slate. Let me just grab slate first. So slate is number 11. So we're going to put that here next to number 10, which was the negative for the incoming power. And then the green 13 is what I'm using for my ground. So blue went to green, and that's what we're going into here on the number 13 right here, where it's the one next to the corner, not quite in it. So this is what we have so far. All I need to add now is my CPC cable, which again, the green is cut off. So it's a 5-wire CPC cable minus the green. So we got 4 wires left. Black and red are the most straightforward. So let's just do those first, because they're going to be actually the same colors as this. Because if you remember before, we had red going to red, and that's pin number 1. So that's going to be right up here in the corner. And I'm going to see if I can push this in with my fingers, but this is where I might need my needle nose pliers. Oh, looks like I got it in there, and it's situated and it's nice and snug. The black that I want to use is the number 3. So we're going to just go right here. See if I can push this in without my pliers. I might need the pliers on this one. It doesn't want to move. So I like having some straight pliers and some bent pliers too, just because these bent nose sometimes will give you a better angle to see what you're doing. But there we go. Looks like that's in. Now the way that went in looks like it was a little crooked. So at this point, I'm actually going to put the locking wedge on just to make sure everything's still lining up and it's fine. So I'm going to take it back off again. And now we have just the low level wires left. That's the orange and the white. And so we want to look for the orange, because that was the same color too, if you remember from the first segment. So orange is number 5. Let's get over here to number 5, which is this opposite corner. And I think I can get it by hand. Oh, I'm almost there. But I'm going to need my pliers just to be sure that I have it in all the way. There it is. Now it's in all the way. And now what do we do with our white? That was on violet. So violet is number 12. And that is going to be down here in this first row in between 2 of these proc switch wires. So here is 12 right in the middle of the bottom row. Because those proc switch wires are in my way, I'm going to just grab my straight needle nose here from the get-go so that I don't mess up those other wires. And now I'm just going to work it in. So now it's just a matter of patience. And again, I said it before in the other segments, with these amp seal connectors, that female end is actually moderately fragile. So don't reach in here and try to pull with the needle nose. You can really mess them up, and then you're going to have to clip it off and start over once it's deformed. So you don't want that. I had to have one difficult one to show you that they don't all just go in easy for me either. Okay, they're all flush. And now I want to put my locking wedge on and pop it in there. And now I can also double check to make sure I can see all of my terminals and that none of them actually got pushed back in there. So now the only other piece left from our kit would be these white plugs, and you don't need them unless you made a mistake and put a wire in a hole that was the wrong one and now you've left it vacant, because there is a membrane inside of these that will keep out the water ingress. But if you accidentally put a terminal into one of the holes by mistake and then pulled it out, that's where you just grab one of these plugs and put that in there to make sure it's plugged. And there's no harm in using the plugs to plug any holes that don't have wires, just if you're concerned, but you don't necessarily need to do that. So now this wire is all set up. We've built a harness specifically for our G3 that has the CPC connector, the incoming power, which I have a 2-pin Deutsch on, and then our proc switch. So this can now be tested in the same manner as in the first segment, where we're just gonna hook it up to the GLCX controller, grab a pump. Now we can just test it and confirm that everything's good. I'm gonna let you do that on your own because it's the same process as what I showed in that first segment. So hopefully you found this video helpful and informative. If you have any questions about Graco pumps, controllers, any of our wiring harnesses and other accessories, please feel free to contact us because we are always happy to hear from you.